Hello and welcome. We'll get started here in a couple more minutes. Come on in, find a seat, make yourself comfortable. We'll give it one more minute. At the top of the hour, we'll start. Okay, there's my beep. Let's get started. Good afternoon and welcome all. My name is Alan Barn. I'm with COEH Northern California. And on behalf of the NIOSH-supported education and research centers throughout the country, we're pleased to present the 2021 ERC Ergonomics webinar series, where we offer free monthly webinars on various topics on human factors and ergonomics. This collaborative effort on behalf of each ERC's continuing education program aspires to provide access to current research supported through NIOSH ERC programs. Thank you for joining us today. All participants who logged in with their registration email will receive a link to the recording and an evaluation form that will qualify you for a certificate of completion worth one continuing education contact hour. Upcoming webinar, December 1st, 2021, we have COVID-19 wastewater monitoring, tracking SARS-CoV-2 infection dynamics through genome sequencing. You can register for that webinar and other upcoming webinars, of which there are many, at coeh.berkeley.edu/webinars. For today's webinar, you'll be muted during the presentation. If you'd like to ask a question, and we do encourage that you do so, please enter it into the online Q&A, and we'll save some time at the end of the presentation to address those questions. It is difficult for me to sift through the chat, so I would prefer, if you wouldn't mind, dropping your questions into the Q&A panel. Thank you. As I mentioned, today's webinar will be recorded and will be made available along with many other past webinars on COEH Northern California YouTube channel. Please like and subscribe to our channel to help us continue to grow. Our speaker today is Rachel Zeiler, and the title of the presentation, Effects of Chronic Heat Stress and Shift Work on Postural Stability in Firefighters, a pilot study. In collaboration with the University of Cincinnati ERC. Rachel is a PhD candidate at the University of Cincinnati, studying environmental and industrial hygiene. Her work is currently focused on evaluating the effects of physical and chemical hazards have on functional outcomes, with her dissertation work focused on early life lead exposure and its impact on postural stability and bone health in adulthood. Rachel works in the Early Detection and Degenerative Diseases and Innovative Solutions Lab, led by Dr. Amit Bhattacharya, in the Department of Environmental and Public Health Sciences. And with that, it's my pleasure to hand the mic over to Rachel. Welcome, Rachel.
Thank you. Thank you for that introduction, Alan. Hi, everyone. Thank you all for taking the time to listen to me speak today. I started on this project in Dr. Bhattacharya's lab back in 2019, so I'm really excited to finally be sharing some of this work. I'm going to turn my video off for the rest of the presentation, so my slides will be a little bit bigger. I want to begin by acknowledging the people. This work was partially sponsored by the National Personal Protective Technology Lab, and myself and other students working on the project have been supported through the University of Cincinnati's Education and Research Center, sponsored by NIOSH. So as an outline for my talk today, I'll start by going over a brief background of the hazards of firefighting and how they impact postural balance. I'll talk a little bit about some of our previous work with firefighters. I'll give an introduction of our pilot study this work is from, and then go into an in-depth discussion into the methods we use these data, and with sharing some of our preliminary findings. Shift work is defined by working outside of typical daylight hours, usually from 7 a.m. to 6 p.m. Almost 30% of workers in the US have work arrangements that are considered shift work. So this could be working early mornings, evenings, or night shifts, and working swing or rotating shifts as well. Shift work has been associated with a variety of chronic health conditions, increased workplace and motor vehicle accidents, a higher prevalence of sleep disorders, and increased psychosocial stress. Firefighters typically work a 24-hour on, 48-hour off schedule, so they work every 3 days. Firefighters on the schedule are considered shift workers. However, their shift work is a little bit different. Typical shift work. During the day, firefighters are expected to work a typical 8-hour day. So during the day, they might do preparation work, like making sure their truck and gear are ready. They do scheduled training with their department or in specialized teams. They also do housework, like keeping the firehouse and trucks clean. And they have time to take care of any reporting or documentation for emergency calls. At night, firefighters are encouraged to relax and sleep at the firehouse. However, they have to be ready to go at any time of night if there is an emergency. So even though they aren't necessarily awake and working at night, their sleep may be interrupted to deal with emergencies if they arise. Emergencies that do occur during the night disrupt the firefighter's sleep, putting them at a risk for short sleep or partial sleep deprivation. Short sleep and sleep deprivation have been associated with a variety of different adverse health conditions, but for this, we're mostly focused on postural balance. So sleep deprivation has been associated with poor postural balance, which may put firefighters at an increased risk for falls. Dr. Bhattacharya and his team have been working to understand how shift work impacts postural balance in firefighters for the past 15 years. One of the earlier studies by our group looked at how extended 48-hour shifts impacted postural balance. So they conducted static balance tests every 12 hours of the shift and found that after 36 hours on the job, firefighters so if a firefighter was called to an emergency near the end of their shifts, they may be at greater risk for falls compared to the start of their shift. However, this association wasn't statistically significant, but even without statistical significance, the study showed that extended shifts may be contributing to the high rate of slip, trips, and falls in firefighters. Firefighters are also regularly subjected to heat stress during their work. Heat stress is defined by NIOSH as the net heat load to which a worker is exposed from the combined contributions of metabolic heat, environmental factors, and clothing worn, which results in the body. For firefighters, environmental heat can come from radiant heat from the fire and high ambient air temperature and humidity. The tasks firefighters perform are typically very physically demanding, causing an increase in metabolic load. Firefighters also wear heavy personal protective equipment, or PPE, to protect themselves from burns and falling objects. However, this PPE doesn't allow the body to dissipate heat, which is a risk factor for heat stress. Other personal factors like health conditions, age, obesity, and other factors are risk factors for heat stress as well. Without adequate cooling and rest, heat stress can lead to acute heat disorders that can be fatal. So this is another study by our group. In this study, firefighters performed 3 live burn training and balance measurements were taken before and after. So the red line here represents, or I'm sorry, the blue line here represents their before exposure, before the live burn training, and the red line represents the after. So you can see in the blue line, there isn't too much movement. It stays relatively close to the center compared to the red line, where the pattern is very erratic and very off center. So firefighters had a much harder time maintaining balance after firefighting in this study. They also found that an increased core body temperature or heat stress was associated with poorer postural balance. So the work I presented has led up to the most recent work done by our team. This study began in 2015 with the objective to assess the impact of firefighting on brain function and postural balance. So then there's another part of this study done by Dr. Kim Cecil at Cincinnati Children's Hospital, where they performed functional MRIs to compare brain activation, different pictures and videos of people's balance. So the second part of the study, which I'll be sharing today, is to understand how firefighting impacts static and dynamic postural balance. So after the MRI, the firefighters come to our lab and go through 8 static balance tests and 6 dynamic balance tests. So today I'll be showing what we did and some of our preliminary results for this study. So just as an outline of the methods, I'll talk a little about our recruitment for this study, the questionnaires we use to quantify exposure, and our static and dynamic testing protocol, and also the perceived sense of postural sway and instability survey. For this study, we recruited 22 male firefighters from the Cincinnati and Northern Kentucky region. Participating firefighters could be part-time or and had to be within the ages of 35 to 45 years of age. Exclusions were made based on health conditions affecting postural balance or vision, mental health diagnoses, and the ability to undergo an MRI scan. So these were some of the questions asked on our health and work history questionnaire. Questions included the number of years spent as a full and part-time firefighter per week over the past 6 months, the average number of EMS runs per week over the past 6 months, and the total number of times each firefighter had been in a structure fire or heavy smoke conditions in the past 6 months. Heavy smoke conditions would include any live fire or live burn training as well. So more specifically, we use the numerical values reported for those questions to quantify exposure. So to quantify shift work, we use the reported total number of years spent as a firefighter, which included both part-time and full-time, and the average number of hours worked per week as they reported. We also use the reported average number of EMS runs per week. And to quantify heat stress, we use the number of heavy smoke or fire runs, or heavy smoke or structure fire runs the firefighters reported for the past 6 months, and divided it by 26 to get our it's the same. So each of these was used in our multivariate analysis, which I'll talk about in a couple slides. We also used age and BMI as additional cofactors for our analyses. So the first test performed by in our lab was static balance testing, also referred to as sway testing. During static balance testing, the subject stands on a force platform and is asked to remain as still as possible for 30 seconds. We use three test conditions used to test the different sensory afferents, which are vision, or the ability to see where you are compared to your surroundings; proprioception, which is your body's ability to sense movement through the sensation of muscle contractions and pressure; and the vestibular system, which is the sensory system that provides our brain with information about motion, head position, and spatial orientation. So we maintain balance while standing or walking. We're relying on all three of these sensory afferents to keep us from falling. So the first test condition is referred to as A, which is standing on the force platform on 2 feet with eyes open. This test condition was also used as a baseline for some of our analyses, since none of the sensory afferents are being tested during this test. This is a low difficulty task because the subject has all 3 sensory afferents available for use. The next test condition is B, which is almost the same thing, just with eyes closed. So the subject stands on the force platform on two. This removes vision and forces them to rely on their proprioceptive and vestibular systems to maintain balance. This is a medium difficulty test just because of the removal of the visual input. The next is test L, which is on one leg. So the subject stands on one foot with his eyes open during the test. This test is high difficulty. The firefighter can use their vision and vestibular system to orient themselves, but they're heavily relying on their proprioceptive system and the sensation of pressure in the foot and muscle contraction throughout the foot and leg to keep themselves from falling. The final test is M, which is standing on one foot with eyes closed. So this is the most difficult test because the firefighter can only rely on their proprioceptive and vestibular system. So again, they're using the sensory input from their muscles, but because of the removal of vision, they're heavily relying on their vestibular system for spatial orientation. Each of these tests are 30 seconds long and are repeated in reverse order. So A, B, L, M, B, L, A. And then the average of 2 trials is used for analysis. The subject stands on a force platform. The static balance test. The force platform we have in our lab is from AMTI and uses forces and moments in the mediolateral or ML, anterior posterior or AP, and vertical axes to measure changes in the center of pressure. Center of pressure in basic terms is the location where a pressure force is applied. So as we stand, even while we're standing still, our center of pressure moves slightly. So to measure balance, we measure slight changes in the center of pressure. For this analysis, I'm going to present our findings for sway area, sway length, and mediolateral and anterior positions, which I'll describe over the next few slides. We also counted the number of falls during each test, and they're reported in the results. So a trial is considered a fall if the firefighter lost balance and needed to step off the plate or put their other foot down during the 1 foot test. So sway length is defined as the total distance traveled by the center of pressure during the 30-second test. So in this figure, the blue line here represents the movement of the center of pressure throughout the test. And if we were to stretch that blue line out and measure it with a tape measure, that would be the sway length. Sway area is defined as the total area encompassed by the movement of the center of pressure in the horizontal plane during the test. So when we draw out the center of pressure, like we have here in this figure, the total area it covers is the sway area. So here we use this blue outline to measure our sway area. We also measured mediolateral excursion, which is the net deviation of the center of pressure in the mediolateral direction. So in this figure, the mediolateral excursion would be the distance from here to here. And then similarly with anterior posterior excursion, the anterior posterior excursion would be the measured distance from here to here. And this image also includes the stability boundary, which is geometrically defined as the outside edge of the feet. Here, this pink area, here we're using the functional stability boundary, which is 80% of the footprints, because that is a limit of the base of support for static balance. Dynamic postural balance is balance while doing dynamic tasks. So here we do a functional gait analysis using instrumented timed up and go tests, which is basically just walking while wearing sensors. So the firefighter wears 5 wireless inertial link sensors that measure linear acceleration and angular velocity while they walk. So the firefighter begins seated. They stand, walk 7 meters around a cone, and then walk 7 meters back. And the test ends when the subject is seated back in the seat, in the chair. And the firefighter was instructed to walk at the normal pace. During the testing, the firefighter performed 3 single task ITUG trials, like I just described. And then they do 3 dual task trials where they're asked to perform serial subtractions by 3 from a given number. So they're given a random number before the test starts. When they stand, they restate that number. As they walk, they continuously subtract 3 from that number. So if they're given 100 when they stand, they would say 100, 97, 94, 91, and so on until they're seated in the chair. So the purpose of the dual task is to test the firefighter's motor function while performing a mentally stimulating task. Firefighters are commonly performing complex cognitive decision-making while performing physically demanding tasks. So the dual task test here allows us to assess their gait pattern while multitasking. As I mentioned, the firefighters wear 5 sensors, 1 on their mid-back, 2 on their right and left thighs, a couple inches above the top of the kneecap, and 2 on their right and left shins, 3 inches before. Sensors we have are from Lexus, and they have a 3D gyroscope and 3D accelerometer to measure angular velocity and linear acceleration in the mediolateral, anterior, posterior, and vertical directions. So these measures were transformed using a custom software built by our lab to quantify gait variables. Just because of time, I'm not going to explain each outcome variable, but I'll talk a little bit more about each of them in the results. But basically the analysis finds walk times, turns, gait events, stride lengths, cadence, and lower extremity joint ranges of motion. We also use the subject's perceived sense of postural sway and which I'll talk about in a few slides. Each subject was asked these 4 questions after each static and dynamic test. How much did you feel your body sway? Did you have any difficulty maintaining balance? Did you feel at any time that you would fall? And what would you say was the overall difficulty of the task? Subjects were asked to answer based on the numbers that range from 0 to 2. And these scores were recorded, and the sum of these scores were used as the subject's subjective rating of postural sway. For analysis, we use the average of 2 or 3 trials, depending on the test. So for example, for single task dynamic balance testing, there's 1 score, and for dual task dynamic balance testing, there's another score. For our analyses, we use descriptive statistics and t-tests to compare different test conditions. We also did a multivariate linear regression to understand the relationship between independent variables, so heat, stress, and shift work metrics, and our dependent variables, or the balance outcome metrics. BMI and age were also added to the regression as cofactors. We also performed backward elimination model selection on the multivariate linear regressions as well. So the model selection was used to pick the most significant independent variables, the exposure variables, and remove independent variables that were less important to the model. So now I'm going to go move on to some of our preliminary results. So just to give a little background on the cohort studied, our cohort contained 22 male firefighters, and all but 1 of the firefighters was full-time. 19 of the 22 firefighters worked a 24-hour on, 48-hour off work schedule. The firefighters were between the ages of 30 to 44 years of age. The average BMI was 29, which is typical of the average BMI of a career firefighter in the US. The firefighters studied had an average firefighting experience of 14.7 years, ranging from 1 year to 24 years. And that was a combination of both part-time and full-time work. On average, firefighters reported working an average of 54 hours per week, which is also average for career firefighters. They usually work around 50 to 60 hours a week. These firefighters reported going on an average of 15.2 EMS runs per week and 0.16 structure or heavy smoke fire runs over the past 6 months. So these are the descriptive statistics for the static balance testing. So each plot represents one of the static balance outcomes. So mediolateral excursion, anterior posterior excursion, sway length, sway area, and the PS/PSI score. Or above its bar. So A, B, L, M, and the means are located there. The mean of each outcome metric increased with each condition, and each were significantly higher than the baseline or condition A, which is expected. So as the test condition gets more difficult and more of the sensory afferents are tested, we should see more movement in the sway pattern. In every condition, anterior posterior excursion was higher than medial lateral excursion. So this means that during the sway testing, subjects were predominantly swaying along the anterior posterior plane or from front to back rather than side to side. There were no falls during conditions A and B on 2 feet. During condition L, standing on 1 foot with eyes open, 4 falls occurred. And during condition M, 1 foot, eyes closed, 39 falls occurred. So there were only 5 trials that did not end in a fall for condition M. So this is the results from the backward elimination model selection. I only included the model that yielded an R-squared value over 30% in this table. So conditions A and L did not have any models with that success. Only models from condition B, 2 feet with eyes closed, and M, 1 foot with eyes closed. Because of the falls during test condition M, we did lose some data. So we only have an N of 13 subjects for that test condition. We use the Shapiro-Wilk test to test the normality, and all outcomes came from a normally distributed population. But I'm going to explain these results over the next few slides. So for condition B, the average fire runs per week and EMS runs per week were determined to be the most important predictors for the model with perceived sense of postural sway and instability. This relationship described by the model is really interesting because it's showing that more fire runs and more EMS runs reported, the lower the perception of sway. So I haven't looked into the objective measures of sway yet and comparing them with the perceived, but I think it'll be really interesting to see how those compare. For condition M, standing on 1 foot with eyes closed, age and average hours worked per week were predictors for sway area and sway length. So as age and hours per week increased, so did the sway area and the sway length. And these are both in the expected directions. So as our exposure increased, so did our postural sway. We also saw that average fire runs per week and BMI were indirectly associated with mediolateral excursion and the PS-PSI score. So as fire runs and BMI increased, movement in the mediolateral direction and the PS-PSI score decreased. These are all of the outcome variables from our GATE tests. So there were statistically significant differences between single and dual task, which is expected. The differences were noted in trial duration, or how long it took the firefighter to complete the trial, step count, so the number of steps taken during the trial, cadence or steps per minute, double stance mean, or how long the subject is on 2 feet while walking, the turning vertical angular velocity, or the velocity in the vertical plane as the firefighter turns around the cone, stride mean, how far the feet land apart, and hip range of motion, and the PS-PSI score. Surprisingly, there were not any or just one of the turning variables that was significantly different. I expected to see a lot more difference during the turns. Turn duration was slightly more during, so like the time that it took them to turn, but that was not significant. Again, this is for dynamic balance, so the GATE assessment. I only included models that yielded an R-squared over 30% here. So for single task, 4 of the dynamic balance variables yielded models with an R-squared over 30%, and 3 of the dual task variables had models with an R-squared over 30%. We again use the Shapiro-Wilk test to test the normality, and all of the outcomes came from normally distributed populations. But I'm going to summarize these over the next few slides. So models with step count, angular velocity while turning, and linear acceleration while turning were all associated with job tenure. So the more work experience a firefighter had or job tenure, the more steps they took and the slower their turns were for single and dual task tests. Taking more steps is a sign of poor balance while walking. If we're walking on a slippery surface, we don't take long leisurely steps. We take controlled steps closer together, so our center of gravity stays within our functional stability boundary. So GATE outcomes associated with job tenure were in our expected direction. Average hours worked per week was a predictor for longer single stance times, or the amount of time spent on one foot while walking, faster turns, and longer strides. All of these gait outcomes are associated with better balance. So again, someone who feels out of balance will not be taking long strides and turning fast. So this model direction. Fire runs per week was an important predictor for step count, angular velocity while turning, linear acceleration while turning, and stride length. So firefighters that reported more fire runs took fewer steps and turned quicker and had longer strides. This again is not in our expected direction. EMS runs per week was an important predictor for step count during single task. So the more EMS runs a subject reported, the more steps they took during their dynamic balance tests. And this is in our expected direction. Age was an important predictor for step count, angular velocity, and linear acceleration while turning. However, the association was different for single and dual task. So in single task, older firefighters took more steps and turned slower, showing postural instability. But during dual task, older firefighters took fewer steps and turned quicker. So this could be showing that older firefighters performed the multitasking, the cognitive and motor test, better than the younger firefighters. So I think that's really interesting. So just as a summary of the static and dynamic balance assessments, average age and average hours per week were associated with poor postural static balance, but this was not the case for dynamic balance assessments. During dynamic balance assessments, average hours worked per week was associated with better gait outcomes. So what we categorize as exposure was associated with better balance. We also saw that older firefighters showed better gait during the dual task, suggesting that older firefighters perform cognitive motor multitasking better. And finally, job tenure or the chronic exposure may be associated with poor postural balance during dynamic testing. This isn't particularly balance related, but we did have some of the firefighters fill out the Berlin questionnaire for sleep apnea. So this is a 10-question survey to assess a person's risk for developing sleep apnea. So this is not a diagnostic test, but can only be used to assess risk of developing sleep apnea. The survey questions in category 1 are based on breathing and snoring. So do you snore, the frequency and volume of snoring, and if it asks if anyone has ever noticed that you've stopped breathing while sleeping. Category 2 is based on fatigue. So tiredness or fatigue after waking and falling asleep while driving. And the third category is for high blood pressure and BMI. So the Berlin questionnaire were scored according to their directions. We determined that 7 of the firefighters, or just over 30%, were categorized as high risk for developing sleep apnea. While this is a very small sample size with only 21 subjects, our results mirror what's in the literature. So over 8% of firefighters, or 28% of a cohort of almost 7,000 firefighters screened positive for sleep apnea, and most were undiagnosed. However, in that study, they didn't look at the effects of job tenure. So of course, these are just preliminary results, not adjusting for age or other cofactors. But we found that when we separated our small cohort by job tenure, more of the firefighters that had a longer job tenure, over 15 years of experience, were high risk for developing sleep apnea. So just about half of the firefighters with more than 15 years of experience were high risk, while only 20% of the firefighters with less than 15 years of experience were high risk. So I thought this was really interesting and should definitely further in the future. Sleep apnea has been associated with poor postural balance. So this could definitely be playing a role here in our cohort as well. As I mentioned in the background of firefighters, firefighters are shift workers, but their schedule is a little bit different. So it's possible that the presence of sleep disorders or sleep apnea are having an effect on postural balance here in this study, but we just haven't looked into it yet. So just as a summary for my talk today, acute exposure to heat stress and shift work have been shown to cause poor static postural balance. And our pilot study shows evidence that chronic shift work or a long job tenure is associated with declining postural balance. Sleep apnea is prevalent in firefighters, and this effect may be exacerbated by job tenure. The relationship between sleep disorders and postural balance should be further investigated. This study did have a few limitations. First, the sample size was relatively small. The small sample size may have limited our power of our significance. The exposure data that was collected using the work history questionnaire is also limited by recall bias because it's self-reported. In the future, researchers should use a measurable exposure variable to prevent this limitation. The subjects in this study were recruited from a convenient sample, so they're all from Cincinnati or Northern Kentucky region, and are structural firefighters. So these results shouldn't be generalized to the entire firefighting population. So I included my references, and I would also like to thank the team behind a lot of this work. I'm so thankful for all of my experiences and opportunities. Is learned so much from working with our team. None of this work would be possible without them. So I'm really thankful for them. So thank you all again for tuning in today. I can take any questions now, but I've also included my contact email as well as my advisors if there are any questions that we can't get to in this time.
Thank you, Rachel. That's a fascinating presentation. I want to apologize to the group for our connection. We did have some buffering occurring throughout. I'm quite sure that was for everybody and not just for me. But I don't think there were any substantial gaps in the communication. It was just unfortunate. So my apologies for that. We did test things out as we always do, and we didn't have any buffering issues during that period. But we did this time. Anyway, okay, so let's get to a couple of questions. I have one here that says, did SCUBA or SCBA include turnout gear? I think that's the question here. So it says standard uniform, comma, turnout gear, and SCBA. Did SCBA include turnout gear? Does that question make sense to you?
No.
Okay, I'll ask the participant if they could restate that question for us. I will pass it along. Okay, next question. Were other tests of cerebellar function administered, and was the data stratified by alcohol consumption?
So we didn't use any other testing in our lab. I'm not sure if they did during the fMRI. If perception of balance and how they perceived other like human models to be walking, and if they perceived that like them as out of balance or not. Was the data stratified by alcohol consumption? We did collect information on alcohol consumption, but I don't think there were any of the firefighters that reported. We asked if they had consumed alcohol within the past 24 hours before testing. I don't think there were any that had. So no,
You did cut off there at the end, but I understood you to say that you did collect that data, but you didn't get any reports of people having consumed alcohol just the day before the study. Is that correct?
Yes, sorry. We collected data on their alcohol consumption for the 24 hours leading up to the testing, but no one reported using any alcohol, so we didn't include it.
I see, but you didn't. I'm not sure if the. I think the questioner's question was more chronic use, perhaps. Did that data get collected at all?
No, we did not ask about chronic use of. I think that actually might have been in our exclusion criteria. We couldn't have anyone that has a history of drug use or alcohol abuse.
I see.
But I would have to check on that.
Okay, thank you. Okay, so next question. Do you have information on the time of day where the EMS or fire runs occurred, so day versus night, so you could more directly evaluate interruption of sleep? This could be valuable for refining your model.
We did collect, I think, the EMS runs of the last shifts. So firefighters came into our lab, or just in for testing. They had to be 24 hours off of their last shift. So there had to be a full day in between when their last shift was. So we did collect information on when their last fire runs were, or excuse me, EMS runs were. And that would definitely be something good to look into.
Thank you. Okay, so let's see, this is a bit long. I'm just going to read it verbatim. Some research suggests postural sway, measured as total path length from medial lateral to anterior posterior, may return to baseline relatively quickly, 13 to 20 minutes, after an acute exposure, e.g. tests involving exercise. Can you describe the timing of postural sway evaluation in your study in relation to your exposures of interest? That is to say, heat stress and shift work. Were you able to evaluate acute versus chronic effects of these exposures on balance? And are there plans to collect a second evaluation from participants? I realize that was a very long question.
So we weren't measuring any acute exposure here. The original plan for the study was a little bit different, where there would have been that, but due to technical difficulties, we were able to accomplish that. So we were kind of just looking at the long term of how just being a firefighter for years has impacted their balance. Unfortunately, since we weren't able to collect any acute exposure.
I see. Thank you. Do you know how these outcomes in firefighters compare to the general population or other worker groups?
That's a good question. As for the balance, I know there have been studies looking at exposure to heavy metals or neurotoxic chemicals and how those impact balance. And I know there's research on like sleep deprivation and sleep disorders and how they impact balance as well. I don't know how firefighters compare in that sense, but I do know that firefighters do have a higher prevalence of sleep apnea than the general population.
Yeah, that was fascinating to me. Okay, thank you. Given the weight that firefighters handle, could the shorter, more repetitious steps relate to a natural adaptation to the job requirements? The questioner has seen this pattern when a firefighter handles a lower and higher weight ladder.
Good point. That's not something I've thought of or we've looked into, but will definitely be helpful to look into when we're working on this more in the future.
Great, thank you. Okay, next question. The participant says, great job, so great job, pass that along to you. And it's very impressed with all of the gait outcome measurements. Was this group also monitored core temperature, and were functional MRI done?
So we didn't measure the core body temperature during the study just because we weren't, there was no like acute exposure, as I mentioned earlier. The original plan for this study was for them to wear a heated vest and then look at differences before and after. But unfortunately, the heated vest didn't work out. So we didn't measure core body temperature for this because there was no acute exposure. And then MRI done. That's not the work that I've worked on. There is like other, Dr. Cecil and her postdoc have been working on that. So that would be a question for them.
Understood. So the original questionnaire came back regarding the breathing apparatus. It says that your graph of previous studies identified standard uniform turnout gear and SCBA. Do you know if SCBA included turnout gear?
I can't remember specifically. That's from a published paper, so I could look it up and see. I can't remember exactly if it was included or if it was separate.
Okay, thank you. And just jumping over to the chat real quick. This is also a little bit long, but I'm just going to read it to you. We are looking, this is from verbatim from the questionnaire, we are looking at the impact of heat stress and heat-related illness in baseball and softball umpires who work multiple games during a tournament weekend. Some umpires working 9 to 11 games, which take 2 to 3 hours each to complete. The plate umpire must wear protective gear behind the dish during nearly half of the games. With age and other confounding factors such as diabetes, high blood pressure, respiratory illness, and cardiovascular disease, we believe there's a high risk of heat strain during the summer months. How does your data compare to this situation?
That's a good question. So obviously they're a little bit different. Firefighters aren't typically experiencing heat stress every single day. I think they do like multiple trainings every month, but it isn't, every day, like kind of what you're explaining. So there is that difference.
Okay, that's fine. Thank you.
Shift work as well.
I'm sorry, what was that last piece?
There's an addition of shift work as well. So in firefighters, their shifts or their sleep can be interrupted during the night. So that is impacting their balance as well, which might not be true for your umpires.
Yeah, I've got you. Do you happen to know if the sleep apnea improves with retirement? So after ceasing this type of work, are there any reports of the sleep apnea improving?
That's a good question. I haven't looked into that, but I know that sleep apnea does improve with treatment. So if you're receiving like treatment for sleep apnea, it can, it doesn't, you have less of the effects of the sleep apnea. So it can help with the balance or the cognitive function and all that, and the health conditions associated with sleep apnea.
Okay, thank you. And finally, can you, well, actually one more came in here. Has balance impact from heat stress been studied in wildland firefighters?
That's a good question. I haven't looked into the literature on that, so I'm not sure. But that would definitely be something interesting to look at.
Okay, thank you. Someone is answering this SCBA question. It says, yes, SCBA did include turnout gear. Okay, Paul, there's your answer for you explicitly. So I will just close by having you talk briefly, if you don't mind, about future directions here. What's next? What's cooking? What's going on?
Yeah. So with the rest of the study into some of the relationship between sleep apnea and balance. So what we found in the risk for sleep apnea and how it compares with those specific subjects and their balance. I also would like to explore nonlinear associations as well, since we had very few of the linear associations be significant. I think that would be interesting to look into. We also have questionnaires on burnout and PTSD that the firefighters filled out when they were in our lab for testing. So I hope to soon be able to analyze those because we haven't gotten to those yet, and then be able to compare those to both the sleep apnea work and our balance work as well. And then in the future, they are hoping to expand this study. This was just a pilot study. So we are hoping to expand to a larger cohort so we can understand the more chronic effects of heat stress and shift work. And then done work with pre-cooling methods to prevent heat stress. So the subject wears like a pre-cooling vest before they go into a live burn, and it helps to keep their core body temperature lower longer, I guess. So I think hopefully all of those things. I know it's a lot, but
can I add one to your list? What about something to make this? You mentioned that the results were not generalizable based on your population. What steps can you take nationally, maybe via survey or something of that sort, to make these findings more generalizable?
yeah, that's a good question. If we were to use like the data that we collected here, we would have to collect data from people from multiple different climates and maybe even expand to wildland firefighters as well. If we were just using a survey, we could ask just about falls, like how often they experience falls or near falls. So that's something we could do to generalize it a little bit more. It is kind of different just because they're of the different climates throughout the US. Just the amount of fires that each region experiences and how much more work each regional firefighters do. So.
Okay, well, thank you, Rachel. So I don't see any more questions at this time. So I think we will move to closing remarks here. You can learn more and register for our upcoming events at coeh.berkeley.edu. And you can also subscribe to our YouTube channel, where you can find recordings of previous webinars and other events. As a reminder, if you're logged in today with your registration email, you will receive a link to an evaluation form that will qualify you for a certificate of completion worth 1 CE contact hour. If you have any questions for us here at COEH Northern California, you can drop us a line at coehce@berkeley.edu. That's coehce@berkeley.edu. And I'll just take this opportunity to say thank you very much, Rachel, for your presentation. And thank you all very much for joining us today. We're finished a few minutes early, so you're welcome. And Rachel, thanks so much.
Yeah, thank you, Alan.
Bye all.